Hello everyone, welcome to the next session of ANSYS Workbench tutorials. In this session, we will solve another numerical on SFD and BMD analysis using ANSYS Workbench. We are going to study about uniformly distributed load that is applied on a beam, and we will see how to analyze such a type of beam. So this is the problem that we are solving. AB is a cantilever beam. On A to C portion, you can see there is a UDL, and on B to B portion, again there is a UDL. The beam is divided into three parts: AC, CD, and DB, and we can accordingly draw geometry and solve it. At end A, there is a fixed support. So now let's get started with ANSYS and find the solution and compare them. Let's go to static structural and double click on it. I'll rename the file as SF BM example 5. I'll right click on geometry, new design modeler geometry. I'll go to XY, look at, the unit is meter. I'll go to sketching and I'll draw a line. I'll give it dimension. The first part of the beam AC is 2 meters. Next, I'll complete the rest part of the beam. This is CD and DB. H2 is 1 meter and H3 is 3 meters. Next, I'll go to concept, lines from sketches. I'll select the sketch 1, apply, generate. Then I'll go to concept, cross section. I'll choose rectangular. I'll change the dimensions. I'll go to one part, one body. I'll choose line body and give it the cross section. Next, I'll go to view, cross section solids, and I can see the cross section here very clearly. So this completes my simple geometry. Next, I'll go to model and double click on it. I'll go to mesh. I'll change sizing from coarse to fine, update. Next, I'll go to static structural. At end A, I will insert fixed support. Between A and C, there is a UDL. So I will choose edge and I'll insert force. Since it is UDL, it is resolved in this fashion, A to C. It is 6 kilonewton, which is acting at 1 meter, which is the beam is divided into half. So I will write here along the y-axis minus 6000. Next, I will apply load between D to B portion, which is again UDL. So I will insert force. I'll change vector to component. I can check here, again it is 6 kilonewton and it is at half the distance from the end B. That is, it is divided into 1.5 meter from end D and end B. So I will write here minus 6000. Next, I'll go to solution because this completes the force and the reaction. So I'll go to solution, insert deformation, directional. I want to see the deformation along y-axis. I will go to probe and I'll choose force reaction. I want to see the force reaction at the fixed end. I will also insert moment reaction because it is fixed support. Next, I'll go to beam results and I'll choose shear moment diagram. I need to define a path, so I'll go to model, construction geometry. I'll choose path. I'll change path type to edge. I'll choose the edges by pressing the control button. Apply on geometry. Next, I'll give the path for the shear moment diagram. And last, I'll choose the beam tool. I will click on solve. So this is the directional deformation that can be seen. I can animate and see the result. Next, I can see the force reaction. Now, since we have applied the force along the y-axis, I would also want to see the reaction in the y direction. So it is 12 kilonewton as we can see here. I will go to this diagram and I can see that this VA over here is 12 kilonewton. From the SF diagram, we can judge that value. Next, I'll go to the moment reaction. I want to see the value along the z-axis. It is 33 kilonewton meter. You can see here at this end, this value is actually 33 kilonewton meter. I have not marked the values here, but that is the value that is obtained. Next, we will go to the shear moment diagram, and this is the diagram that is obtained at 0 meter. That is at the start, you will see the value is approximately 12 kilonewton. It is 11.87. So here you can see it is 12 kilonewton and then these values. So at C, the value over here for 2 meter is 6 kilonewton. So again, you can come here at 2 meter. You can see it is 6 kilonewton and the bending moment will be 15 kilonewton. So this value is also correct. If you go for the theoretical solution, you can find out the values. And next, I would want to see the value at point D, that is at 3 meter from the start. So I'll go down to 3 meters length. I can see here the value is 6 kilonewton and here the value is 9 kilonewton meter. This value also is correct, absolutely correct. There is no close value, it is absolutely the same answer. And at the last point, at 6 meter, you can see that the value of bending moment is almost 0. And for shear force also, the value is almost 0. So you can see the same thing over here. So this proves that the value that we have obtained by both the solutions are correct. You can also see the minimum combined stress and the maximum combined stress on the beam. You can animate and check the results. So that completes this numerical. I hope you have understood the solution. If you have any doubts, please write to me in the comment section. See you in the next session. Thank you.